If you want to take a seat, we're about to get started. Thank you all for coming. For those of you that don't know me or don't recognize me in a suit, my name is Lance Williams. I am the chair of the biology department, and I'm not your MC for tonight, but I'm here to welcome you to come to this event for Darwin Day. Josh is going to tell you a little bit more about Darwin Day. I'm going to tell you a little bit about the biology department. We're one of the host institutions. In our department, we have nearly 400 majors, many of which are involved in undergraduate research. We have a long history of undergraduate research in our program. We have nearly 20 graduate students, and external grant funding in our department is nearly $2 million right now. Our faculty do research, and our graduate students and undergrads do research in a variety of fields, including evolution, ecology, molecular biology, microbiology, and synthetic biology. We are a major contributor to the Center for Environment, Biodiversity, and Conservation, which is a multidisciplinary research and education center that includes 19 faculty from 3 colleges and 5 departments. One of our faculty actually a couple of our faculty have awards from the National Science Foundation. We have awards from Texas Comptroller's Office, from U.S. Fish and Wildlife Service, Texas Parks and Wildlife, Texas Commission on Environmental Quality, U.S. Army. So we have our diverse department with a variety of funding, National Institute of Health. We also have a faculty member that received a Fulbright Fellowship for the last 2 years. So we're a great department, and I'm very happy to welcome you all here. And I'm going to turn it over to Dr. Josh Banta, who is the host for the night.
All right, thanks, Lance. Appreciate it. Okay, all right. So welcome to everyone. I'm Dr. Josh Banta. I'm an associate professor in the biology department here at the University of Texas at Tyler, and I'm also the director of the Center for Environment, Biodiversity, and Conservation. I also want to say, if you're a student here as part of a class, there are sign-in sheets in the back if you're looking for them. I also want to point out that there is another keynote lecture like this one tomorrow night. It will be on a different topic. We will have our same guest speaker, but it will be a completely separate talk. You're all welcome there. I hope that you all can join us. That one will be at our partner institution, Tyler Junior College. Visit our website, darwindaytyler.org, for more information on that. So Darwin Day. These events are timed to coincide with evolutionary biologist Charles Darwin's birthday on February 12th, today, in 1809. So happy birthday, Chuck. Similar events like this one are held annually worldwide for the purpose of recognizing the benefits of scientific exploration and discovery, and focusing on evolutionary biology and biological diversity. These events commemorating Charles Darwin's contributions to science have been going on since his death in 1882. But Darwin Day in its more modern form, like you see here on our campus, traces back to the mid-90s, the mid-1990s, I should say. Darwin Day has been commemorated here in Tyler, Texas for about 10 years. And that's been by the Earth and Space Science Center at Tyler Junior College. But it's been a joint venture of UT Tyler and Tyler Junior College for about the last 6 years, with events now spanning both campuses and integrated together. Darwin Day in Tyler, Texas has grown into a multi-day series of events with sponsors locally, such as the UT Tyler chapter of the Alpha Chi Honor Society, the UT Tyler Discovery Science Place, the UT Tyler Department of Biology, the UT Tyler Department of Social Sciences, and the Earth and Space Science Center at Tyler Junior College. And we have funding from the National Science Foundation and Humanities Texas for this event. So this is a pretty wide-ranging source of funding and sponsors. The events include public science lectures, such as the one that you're here for tonight, moderated videos about evolution, which are available this Friday. I hope you can join us for those videos as well. And activity booths about evolution at UT Tyler, Tyler Junior College, and the Discovery Science Place. Now, there is a large and growing list of organizers, which I'll summarize here for you as briefly as I can. Graduate students in the biology department here at UT Tyler. We have undergraduate students that are members of the Tri Beta Honor Society. Dr. Brent Bill, Dr. John Seal, Dr. Katrine Kellner, my colleagues in my department, Chris Razier, the director of the UT Tyler Discovery Science Place. Over on the Tyler Junior College side, Dr. Tom Hooton, the chair of the physics department, Dr. Betsy Ott, a biology professor, Dr. Doug Parsons, in the physics department, and Danielle Pritchard in biology. I have two special notes. The UT Tyler Department of Social Sciences, which is one of our sponsors, is hosting the East Texas Archaeological and Cato Conference on February 28th and 29th of this month, focusing on the Cato Nation of Native Americans from this area. This year's conference will be in support of the Cato Nation and rebuilding of facilities at Cato Mounds State Historic Site, which were ravaged by some tornadoes. Second note, the UT Tyler Department of Biology is offering a study abroad course in May in Ecuador and the Galapagos Islands, taught by yours truly. The Galapagos Islands were formative for Charles Darwin in developing his theory of evolution, and they are biogeographically unique and stunningly beautiful. You do not need to be a current student to join us. If you're more interested in the Galapagos trip or the archaeology conference, or for other Darwin Day events, visit the events tab of darwindaytyler.org for more information. Okay, now on to this evening. I have the distinct privilege of introducing our keynote speaker, Dr. Stephen Novella, a clinical neurologist and assistant professor of neurology at Yale School of Medicine. Dr. Novella is the best-selling author of the book, The Skeptic's Guide to the Universe. Incidentally, we have books for sale in the lobby after the talk tonight, and Dr. Novella is available for the book signing if you're interested. He's also the host of a popular science podcast that has the same name, The Skeptic's Guide to the Universe. And he has had many prominent guests on his show, including Mythbusters Adam Savage, Bill Nye the Science Guy, and former President Jimmy Carter. He is regularly invited around the world as a panelist at popular science, communication, science-based medicine, and critical thinking conferences. Venues have included the American Association for the Advancement of Science, National Geographic, the Vienna School of Medicine, Rochester Academy of Medicine, and NASA, to name a few. He also runs well-known blogs called Science-Based Medicine, exploring issues and controversies in science and medicine, and Neurologica, focusing on science and skepticism. Many of the Darwin Day organizers and myself are longtime fans of his work. I myself have been listening to his podcast since its inception in 2005, which I just learned puts me in a rarefied group of about 200 people when it first started. It's now over 100,000. So we are truly thrilled that he could join us. And now, without further ado, I bring you Dr. Novella.
Well, thank you so much for having me. It's really an honor to be your keynote for Darwin Day. Thanks to Josh and Lance and everybody for being such great hosts. When I was first asked to give this talk, I'm like, okay, what could I talk about that would be in my lane of science communication with a skeptical theme, meaning science and critical thinking sort of at the same time. And also, pay homage to Darwin's legacy. So I thought, gee, I wonder, do they have a problem with evolution denial in Texas, I wonder? I seem to remember something about that. So in fact, we had on our show, Dan McElroy, you guys remember that name? Very interesting discussion with him. And then we carried that over in written form in my blog, Neurologica, if you're interested. I always love to deconstruct how people come to conclusions, which I find just astounding, right? Like, how can you look at a mountain of incontrovertible evidence and go, nah, I don't believe that. I don't believe it. I believe something else entirely, which has zero evidence to support it. I'm actually going to be focusing tomorrow night on evolution denial itself. I'll be just making very scant references to it tonight. Tonight, I'm going to be talking about science denial itself as a phenomenon. And yes, science denial is a thing, right? It does exist. I often get a lot of pushback when I refer to science denial, people saying, well, you're just dismissing legitimate skepticism about whatever science or whatever claim that you're making. It's just a way to make a personal attack or smear people. For some reason, they think that we're trying to make an analogy specifically to Holocaust denial. But it's like, no, it is a thing. Science denial is a phenomenon, and that's what I'm going to be talking about tonight. What is the phenomenon of science denial? So here are some common science denial. So yeah, Holocaust denial is certainly there. That's more of a history denial one, but it's the same. They use the exact same methods. Again, you're denying a well-established consensus of evidence leading to a conclusion about what happened in the past. Of course, evolution denial. There's many different flavors of creationism, and I'll talk about that more in detail tomorrow night. But the one thing they all have in common is the denial of the consensus of scientific opinion about evolutionary theory. Climate change denial. Actually, this is one of the first topics I started writing about in my science communication career. I actually wrote an article on science denial 24 years ago. And it's really amazing to me how this has almost taken over my science communication. Not so much, we still deal with promoting actual pseudoscience, but actually science denial has eclipsed that in terms of importance. Climate change denial is one of the reasons why. In fact, it's become so huge that the National Center for Science Education, which is an organization dedicated to defending the teaching of evolution in public schools and countering the political machinations of creationists, has had to include a few, I think now maybe 4 or 5 years ago, they started including global warming denial as a topic that they cover, because there's almost complete overlap politically between evolution denial and climate change denial. Mental illness denial, as far as I know, I'm the only one who writes about this in the skeptical science communication universe, probably because it's, I'm a neuroscientist. But yeah, that's a thing. HIV denial, this goes back as long as HIV. It's into the 1980s. You would think that the incredible success of the treatments for HIV would have, put a damper in HIV denial, and it has, but not enough to make it go away. Germ theory and vaccine denial, again, they're not the exact same thing, but there's a lot of overlap, so that's why I include them together. And this is, so there is definitely an anti-vaccine movement, but part of that is denial of the science of vaccines. They literally say they don't work. How could you say vaccines don't work? Well, I'll tell you how in a moment. And neuroscience denial, this is interesting. And of course, this hits me right in my sweet spot, right? Hits me at home. The denial of pretty much all of modern neuroscience, which, you talk to any neuroscientist and it's pretty well established that the mind is what the brain does, right? Your mind basically is your brain. But there's a lot of people who don't want to believe that. And so they deny the neuroscience they deny that modern neuroscience. And again, pretty much 100% overlap with creationism. And in fact, the most online debates I've gotten into with a neuroscience denier is Michael Egnor, who is a creationist, who writes for the Discovery Institute. They're just two flavors of basically the same thing. And also genetic engineering, right? The science of genetic engineering. There is a political anti-GMO movement which engages in a lot of science denial and a lot of the same practices and features. That's usually the one where people get a little queasy when I throw that one in there. They were with me right up until that one. But it's important to include a sort of ideologically diverse range of topics, because this isn't about one political ideology or one religious ideology or belief system. This is a suite of cognitive strategies that people use to deny established consensus opinion, regardless of what direction they're coming from, although there are differences. There are very interesting differences. Now, just think to yourself, I'm not going to ask you to shout out answers, but think to yourself, which one of these topics, of all the ones that I've listed, do you think there is the greatest disconnect between the consensus of scientific opinion and public opinion? So where is there the greatest gap, the most denial? Just think to yourself what you think that might be. Oh yeah, I forgot one at the bottom here. Link between smoking and lung cancer. This one is probably the oldest denialism. This is the first one where there was actually a paid for, dedicated campaign, and they basically wrote the book on how to engage deliberately in a campaign of denialism. All right. Some features of denial. I'm going to talk about these in more detail, but just to give you sort of the list, these are the things that science deniers do. So first of all, they portray themselves as skeptics, right? They say, I'm not a denier, I'm a skeptic. Well, they're actually pseudo-skeptics, right? They're only pretending to be skeptics, but just in the exact same way that pseudo-scientists pretend to be scientists, right? And in the same way, a pseudoscientist is somebody who goes through the motions of science, but they kind of already know their conclusion. And so they're really only using scientific-ish methods to defend a belief they already have. They're not using science to determine if something is true, but to show that it is true. And when you work backwards from the conclusion, you're not doing real science, you're just doing pseudoscience. Same thing, deniers, they know their conclusion, right? Their goal is to deny whatever science offends them, ideologically, politically, or whatever. And the skepticism is all in service to that a priori denial. So in the same way, working backwards, it becomes pseudo-skepticism. So how do they do that? Well, they try to sound reasonable by saying, I'm just looking for evidence. Like they sort of mimic, parrot deliberately the words that skeptics use. And it's been fascinating doing this for over 20 years and seeing my own words reflected back at me by deniers who even in many cases call themselves skeptics. But of course they're doing it wrong, right? I mean, they're just borrowing the form and the style of skepticism without the substance. So they say, I need evidence. I need evidence to believe in something. And of course that's perfectly reasonable. But if your threshold for evidence is impossible by design, that's not real skepticism, right? They magnify scientific disagreements. This is, I think, very common in evolution denial, right? Where, of course, scientists argue with each other all the time. That's part of how science works, right? We don't know all the answers. It's an endless, quest of discovery. And the meat grinder of science is all about debate and criticism, right? That's how science thrives. But that generates a lot of raw material for deniers who could then take those debates, those disagreements, and magnify them as if they call the basic common ground consensus into question. So they exploit or create ambiguity in concepts and ideas and terminology. This one is best illustrated with examples, but I just wanted to put that out there. So there's a lot of confusion, like what is information? What does the word information mean? There's always like a colloquial definition and there's a technical definition. So it's easy to quote a scientist who's using a technical definition to a lay audience and pretend like they're using a different colloquial definition. So they exploit all of that sort of difficulty in explaining technical science to a lay audience. They deny that the consensus exists. Of course, that's sort of, like, again, probably this is the most prominent in global warming denial. There's famously a 97% consensus among scientists, relevant scientists, it's important to say, that man-made global warming is a thing. It's happening. It's probably bad. So if you're going to be a denier, but claim to be on the side of reason, you have to deny the consensus, right? You don't want to say that you're in the 3%. So they do that, and they use a lot of trickery to do that, but the consensus is a real thing. And straight up, they traffic in misinformation, right? They just tell lies. But they mainly tell the worst kind of lies, and those are ones that have a kernel of truth at their center. Because again, it's very easy for them to sound reasonable, and it may be harder to pick out. So in addition to that, they attack scientists. Again, if you're going to be promoting an idea that scientists disagree with, you have to sort of undercut the credibility of scientists. Often very personal, sometimes with literal campaigns of defamation. So they equate the science that they're trying to deny with some moral hazard. This is an emotional argument. Again, evolution's a very common one to say, yeah, if you believe in evolution, then you're immoral, you're amoral, and the country's going to go to hell if that happens. And then here's the thing that's also important to understand about science denial. If your goal is simply to create fear and doubt about a consensus of scientific opinion, you don't have to actually propose a coherent, cogent, alternate theory. All you have to do is cast doubt on the established theory. And that's a lot easier to do. It's a lot easier to criticize and snipe from the fringes than to present a coherent theory backed by evidence, So they don't do that largely. Sometimes they try, usually to comical effect. But largely their goal is just to toss out enough random facts and ideas and notions that just to create a fog of disinformation and a fog of doubt so that people are left with this vague notion that there's something wrong with this scientific theory. And when all else fails, it's a conspiracy, right? This is sort of, I'd say, this is the last refuge of the scoundrel, is the conspiracy theory. Because conspiracy theories solve all problems. You don't have evidence to back up your theory. That's because they're hiding the evidence. What about this evidence against your theory? That's a false flag. They manufactured that fake evidence. Well, these people disagree with you. They're on the take. There's no problem you can't solve with a conspiracy theory. But that's, of course, that's the problem with conspiracy theories, is that because they are irrefutable, they're a self-contained belief system. They are immunized by design from refutation. Therefore, they're worthless as a way of understanding and what's actually real and what's happening. But they're perfect for insulating your belief system. Okay, getting back a little bit to the I'm not a denier, I'm a skeptic thing. There's something in philosophers called the demarcation problem. And that's whenever you have a continuum, there's no way to draw a bright line between two ends of any continuum. So for example, there is a continuum from science to pseudoscience with no bright demarcation line. There's no litmus test you can give. Say, if you pass this test, you're 100% science, and if you fail, you're 100% pseudoscience. It's more that you exist along a spectrum. There are features of legitimate science. There are features of pseudoscience. The more you have of one or the other, the more you are towards one end of the spectrum or the other. Same thing with skepticism versus denier. It's a continuum. There are some skeptics who engage in a little bit of denialist activity because they're just being sloppy, and a denier may have a legitimate skeptical point to make every now and then. It's not, again, 100% black or white. Unfortunately, we have to live with ambiguity. That's the universe we live in. That's just reality. But if you're pretty far to one end of the spectrum or the other, you can reasonably use the label. Like, you're more of a denier than a skeptic, or more of a skeptic than a denier. And here's the other thing. It's very issue specific. So yes, I could talk a little bit in generalities, but we discovered over the last 10, 15 years through research, basically, that any broad question you ask, like, do deniers do X or do Y? The answer is, only some of the time. It depends on the issue. It depends on the population that you're looking at, and it depends on the issue. So the answer to all of our questions about about the phenomenon of science denial is it depends. So I'm going to give you some of those features. Okay, so remember I asked you to think about what you thought was the greatest disconnect between the consensus of scientific opinion and public opinion, and it's about the safety of genetically modified organisms. That is by far the greatest disconnect between scientists and the public, more than global warming, more than evolution, more than the safety of nuclear power, than any other issue. Why is that? That's a good question. I suspect it has something to do with the fact that there has been a 20-year well-financed campaign of misinformation about GMOs. And science communicators like myself were late to the party. It took us a while to figure out this was happening. And by the time we did, we were 10 years or whatever behind the times. And we've been playing catch up ever since. I think we've started to turn that ship around, at least among scientists and other science communicators and self-identified skeptics and people who like to think of themselves as part of the rationalist crowd. But for the broader community, pretty much anyone I talk to, unless they're steeped in the information, you're filled with mostly misinformation about GMOs. And it's not random misinformation. This is a campaign of fear and doubt, exactly like any other campaign of fear and doubt, like with the connection between smoking and cancer, about global warming. It's a denialist campaign using the same tactics and the same strategy. Okay, so here's one of the first studies where it became really clear that not all denialism is the same. And the question is, you look at some topic and you say, what are the demographics of people who believe or don't believe in this topic? And also specifically, what is their scientific background or their scientific knowledge? So in this particular study, they looked at the scientific literacy of people who either accept or reject global warming, and they looked at their political affiliation. And so what they found was surprised the researchers and surprised the community. So typically we think that as, again, if you go back to the classic era of science communication, the Carl Sagan era, 1980s, 1990s, science communicators operated under the theory known as the knowledge deficit model. That's what psychologists call it. The knowledge deficit model means that if you have a belief which is not true, it's because you have a knowledge deficit. So what is the solution to that is to fill the knowledge deficit. You give facts and information, and then people will then align their beliefs to the facts and the evidence. It's like so quaintly naive to say that now, but that's actually what we believed 30 years ago. Carl Sagan himself famously said, people believe pseudoscience in direct proportion to they misunderstand real science. And we've discovered that that's not true. And this is the most dramatic example. So Republicans actually, who disagree with global warming, actually don't have a knowledge deficit. And the more they deny global warming, if anything, the more they understand science. So it's not that they're just scientifically illiterate. There's something else going on. It seems to be that it's political ideology. And in fact, across many, many studies, the single most predictive factor of whether or not you accept the consensus on anthropogenic global warming is your political tribe. That's it. And again, you may congratulate yourself if you're a Democrat who believes in it, but you're just following your tribe too. And of course, if you believe in global warming, but you don't accept the safety of genetically modified organisms, then that kind of drives home the fact that you're just following your tribe. And so you have to be a little bit humble before you congratulate yourself too much. You can take pride in believing something that scientists say that goes against your political tribe. But if it goes in favor of your political tribe, how do you know you're not just following along in the exact same way that conservatives are? Here's another study. And as you can see, it's complicated, right? So they looked at a host of factors and over several topics. And what they found that for climate skepticism, again, I think I would use the term denial, but the authors used skepticism. That annoyed me a little bit. Climate denial, vaccine denial, GM denial. And then you asked, all right, how does it sort out in terms of religious orthodoxy, identity, political conservatism, and a measure of moral purity, right? And as you can see, they're all a little different. Climate skepticism, 100% political ideology, pretty much, right? That's what it is. It's a tribal belief, doesn't really track with anything else. It does track a little bit with religion, but that correlation is completely explained by the fact that republicanism, correlates with certain religious, ideologies. So if you factor that out, it doesn't independently sort with it. All right. What about vaccine skepticism? Pretty much everything, right? Including scientific illiteracy, not climate skepticism, but also very strongly with moral purity. So vaccine skeptics are very concerned with purity. And it says moral purity, but again, other research shows that people's sense of moral purity overlaps with their sense of physical purity. And in fact, the whole concept of purity follows what psychologists call embodied cognition, where we initially start thinking about abstract concepts by making an analogy to physical concepts. We understand the abstract world through physical analogies and metaphors. And so people literally feel physically contaminated or impure in response to purely moral, impure acts, right? And we use the same words. It's not an accident that we use the same words. We literally make those analogies cognitively. Okay, I think I got another slide. Okay, so what you were seeing there was if you deny global warming consensus, it has nothing to do with scientific illiteracy. If you deny the consensus on GMO, that tracks really strongly with scientific illiteracy. If you deny the consensus on vaccines, that tracks also strongly with scientific illiteracy, but also with strong beliefs on moral purity. So each topic is a little bit different. All right. The Dunning-Kruger effect is kind of lurking in the middle of all of this. This is now, I think this notion is a psychological study which gained traction in social media. You see it in a lot of memes. I see it referred to all the time. People, when I see it referred to by non-experts in social media, they almost always get it wrong, which is, of course, that's par for the course. But so if you've heard about, just hands, how many people have heard of the Dunning-Kruger effect before? So quite a few, probably from listening to my show maybe, but so not a random sampling, I would suspect. So what the Dunning-Kruger effect showed is that you see the red line there, the upper line. Do I have a laser pointer here? I don't need one, but just curious. It's all right. The upper, kind of the red and the blue line there. So that's people's actual ability as tested on objective tests, their knowledge in some area. And then the sort of yellow-green line there, I'm a little colorblind, it looks like yellow-green to me. That is so the upper one is their perceived ability and the lower one is their actual ability, right? So you take a test on, whatever, Renaissance composers, doesn't matter, on some topic. And then you assess your relative knowledge to other, like how much do you know about the topic relative to other people? Do you think, are you in the 20th percentile, the 50th percentile, the 8th percentile? So as you could see, the less people actually know, the more they overestimate their own knowledge. That's the Dunning-Kruger effect. It's usually misreported as the less you know, the more you think you know, right? So, but people's self-assessment still goes down with their knowledge, just not as much. Does that make sense? And then in the upper part, people tend to underestimate their relative knowledge a little bit. Not really clear why that is. Are they overestimating other people's knowledge, or are they just being humble? Is it because you don't want to say, yeah, I'm in the top 1% or whatever? This one right here. There we go. So can you see this? Nope. There it is. Oh, it's really tiny. Anyway, so that's the Dunning-Kruger effect. So what does that mean? Here's the other way in which it's almost always used online. And this is, again, the broader principle here. I was talking a little bit about this at lunch with some of the students. That when people first learn clinical thinking skills, like logical fallacies and the Dunning-Kruger effect, they weaponize it in order to argue against other people, right? And the assumption there is that this applies to other people, right? So like one of the ways people falsely summarize the Dunning-Kruger effect is that stupid people don't know how stupid they are, right? They're too stupid to even know how stupid they are. That's not what the Dunning-Kruger effect says at all. First of all, it's not about some people. It's about everybody. It's about all people. We are all on that curve. We're all on many different places on that curve in different knowledge domains. That curve applies to everybody. So while you could laugh at the people at the lower end of the curve, but that's you. You are at that lower end of the curve for something, right? Unless you're an expert on everything, which nobody is. So that's the critical thing to understand about that. But of course, very few people do, right? We tend to think that everyone thinks they're above average, right? That's no one self-assessed themselves in the below 50 percentile, right? Everyone thinks they're at least above average. That's a well-established bias as well. Okay, so the Dunning-Kruger effect is clearly in effect with many of the science denial issues, but again, it's very issue specific. However, there is something known as the super Dunning-Kruger effect, in which people actually do increase their self-assessment as their knowledge decreases. But it's very issue specific. It's most dramatic for genetically modified foods. So people who deny the scientific consensus on the safety of genetically modified foods thought they knew the most about genetics and genetic engineering when they knew the least. So what's going on there? That's not just scientific illiteracy. It's profound scientific illiteracy, but it's not just that, because just that would be the normal decay, right? The normal Dunning-Kruger curve. But they're off the Dunning-Kruger curve. They are actually, their self-assessment is going up as their knowledge is going down. So what's going on there is not just ignorance of the science, it's the illusion of knowledge, right? So people who think that they know more than the average person about genetics, when in fact they know the least about genetics, are filled with a false sense of knowledge and misinformation. But that misinformation is indistinguishable to them from real scientific knowledge, right? And again, don't think that that in and of itself is isolated to just this one group. This is a general phenomenon. It's just more or less dominant with different views, depending on what complicated web of motivations and information ecosystems led you to that belief. And that's sort of another thing you have to understand, is that none of this is in a vacuum, right? We're not just, drones existing in some abstract sense. We are people who are embedded in a social milieu. We are embedded in an information ecosystem. That, I think social media has driven that home in the last 10 years profoundly, partly because it's exacerbated the information ecosystems, right? You could now be living in an information ecosystem that is completely divorced from other people's information ecosystems. And of course, you always think that it's the other people who are divorced from reality, but it's always the other guy, right? But we do have to understand that we're all now in siloed information ecosystems. And so we all need to make a profound effort to get out of those limited ecosystems. Otherwise, again, this is like the canary in the coal mine, or the tip of the iceberg, or choose your metaphor, like the fact that people think, I know genetics, I understand it really, really well. Or vaccines is the other issue. Vaccine deniers also super decay. They knew the least about vaccines when they're tested on actual knowledge, but they self-assessed as knowing the most. They thought they were in the upper part of the curve, but they were actually in the lower part of the curve. Why? Because they're awash in misinformation. And that misinformation, again, is tailored. It's evolved. It's part of it's a dynamic process where you have, it's like a marketplace of misinformation, right? What works well survives and expands. It's adaptive radiation of purposeful misinformation. And it's powerful. And it's living in this social media ecosystem. It's really amazing. That's how you get to, I didn't put this on the list, but this is like the ultimate science denial. That's how you get people who think the earth is flat. Yeah, you laugh because it's the most extreme example. I'm waiting for the next thing to dethrone the flat earthers. I don't know if it will ever happen. But 10 years ago, I wouldn't have predicted that there would be a serious movement of people who really think the earth is flat. That is a profound level of science denial that is hard. You can't imagine. You have to laugh. But when you understand how people get there, you can wrap your head around it. It could make sense. Again, it's part conspiracy theory, it's part misinformation, but it's also just mainly this profound ecosystem of information creating this illusion of knowledge, right? Which is all things that psychologists have known about for decades: confirmation bias, motivated reasoning, heuristic thinking, but just weaponized, right? So our cognitive biases have been weaponized against us. That's what science denial is in the 21st century. All right, so I have to give this example. 50% of people who, this is just generally, thought that GMO tomatoes have genes. Well, non-GMO tomatoes do not have genes. Half. I'm not gonna say that half of you believe that, but I'm saying half of people out there believe that. And yeah, if you're a scientist or a science enthusiast, or you paid attention in your grade school biology class, you know how profoundly wrong that is, but that's the information that's out there, Here's another one. 66% believe that GMO food genes can be incorporated into a person's genes and be passed down. So if I eat a GMO food, the mutant genes are going to get into my DNA and corrupt me, right? That's a purity thing again, right? So this is based upon sort of a nestled hierarchy of misinformation, right? It's the idea that there are mutant genes and non-mutant genes. No, all genes are mutants. That GMO genes are different than non-GMO genes. Nope, they're just genes. That there are people genes and there are fish genes. Nope, they're all just genes. You share 60% of your genes with bananas. 60, I mean, it's a hard number to come up with objectively because of chromosomes and whatnot, whatever. It's a rough estimate. With plants, basically, any plant has the 60% genes are the same with animals because they're like basic genes that do basic things that all living cells need. So is there a difference between a banana gene and a human gene? Not really. There are different promoters and things like that, but they fixed that, right? But the genes themselves, no. All life on Earth has the same genetic code. But people have this sense of contamination and disgust. The notion that there's fish genes in my tomato. This is the whole fish-mato thing, right? And people think that a tomato with fish genes in it are going to be fishy. There's going to be something fishy about that tomato. And again, it naively kind of makes sense if you know nothing about genetics and biology, but that's, again, so there is a knowledge deficit issue there. So the good news in all of it, if I could have a silver lining there, is that there are some science denial problems that you can fix by fixing the knowledge deficit. So not global warming. There's no knowledge deficit driving global warming. There is a knowledge deficit driving resistance to genetically modified organisms. And when you fix that knowledge deficit, it does move the needle. People will increase their acceptance once they realize that everything they believe, all the reasons they have for rejecting it are factually incorrect. I also happen to think that that end of the political spectrum, the evidence does show that they're a little bit more amenable to that sort of correction than the other end of the spectrum, but that's a complicated set of data. All right, I'm just gonna hit upon a couple other, what's my heart, is it 7 o'clock is when am I done, or you mind if I go a little bit over? All right, anybody mind if I go a little bit over? So demands for evidence, I talked about this. So let me give you some examples of it. So you guys familiar with the logical fallacy, moving the goalpost? It's like, show me evidence for show me a transitional fossil. Here's a transitional fossil. Well, no, you gotta show me more. They just keep moving the goalpost. So no amount of evidence is ever enough because you just always ask for more. You could reject entire categories of evidence, right? Correlation does not imply causation. Actually, it does. It doesn't prove causation, but it implies causation. People misapply that logical fallacy all the time. And if I have multiple independent lines of correlation that have only one explanation, that's pretty good evidence. So it's literally true that there is no study which shows that smoking causes any form of lung cancer, because you can't do that study, right? What are you gonna do? Randomize people to smoke and other people to not smoke? That's called unethical, right? You can't ever do that study. But the tobacco industry for decades said there's no proof that smoking causes lung cancer. And they denied the implication of correlation. But if you say, okay, but smoking correlates with cancer, the duration of smoking correlates with an increased risk of cancer, so there's a dose-response curve there. If you quit smoking, your risk goes down. If you smoke unfiltered, that's more of a risk than smoking filtered cigarettes. So every hypothesis of correlation that derives from the theory that smoking causes cancer turns out to be true. And then you have just sort of the principle of parsimony. The easiest way to explain all of these correlations is that smoking causes cancer. And there's no other plausible hypothesis that explains all those correlations. But if your goal is denial, you could say there's no direct evidence that it causes cancer, and correlation is just correlation, doesn't prove causation, right? You could also make unreasonable demands for evidence. Show me one paper that proves that HIV causes AIDS. By definition, there isn't going to be one paper that proves that. You're going to need 100 papers to prove all the elements of that claim. Show me one fossil that proves evolution. I love it when they say that. Of course, there can't be one fossil that proves a complicated process that worked its way out over billions of years. That's not how science works. But it, superficially sounds good enough that if you're motivated to deny the science, it kind of creates that uncertainty and doubt. And then when in doubt, just deny that the evidence exists. There are no transitional fossils. There is no evidence that the Earth is warming. And then, of course, science is messy. Even if we know something pretty clearly, we're pretty sure an asteroid wiped out 75% of life, including the non-avian dinosaurs 65 million years ago. But there's a minority opinion that said it was volcanic eruptions, and there's papers which show both, and it's a complicated issue. It's true enough to tell the public that, yeah, basically an asteroid wiped out the dinosaurs, but if you want to deny that, you can find published studies which give a different answer. Medicine is the same way. I mean, my field of medicine, you can find a paper to show anything you want, anything. There's so many studies out there, most of which are preliminary, most of which are ultimately wrong, because it takes decades and dozens or score of hundreds of papers to really come to a consensus. In the meantime, there's noise that will show anything. If you're willing to cherry pick only the studies which show what you want to show, you can prove anything you want. And you have evidence to cite for it, right? So this is an example of the unreasonable demand of evidence. This is from an anti-vaxxer, Vox Day. He says, statistical analysis isn't enough. It's not enough. I'm going to deny this entire category of evidence. Peer-reviewed meta-studies are of zero value. Pump 1,000 kids full of toxins/vaccines, a little bit of emotional rhetoric in there, according to the complete schedule, and leave a control group of 1,000 completely unvaccinated, then report on how they're doing every 6 months. There's no excuse not to do it. It's entirely doable. That study has never been done. You know why? Because it's unethical. It's never going to be done. Because you can't, this is like standard Nuremberg level, like research ethics that's been, codified in research ethics for decades. You can't randomize people to not receive standard proven therapy. It's unethical. People in a clinical research trial always get the standard of care plus, right? Plus a placebo versus a new treatment. You never deny them the standard of care. We can't randomize children to not get vaccinated. You can look at kids whose parents chose for themselves not to vaccinate them, but then that's not a randomized sample. So those studies have been done, and they do just, these vaccinated kids actually do better than unvaccinated cohorts. But that's not the study he's talking about, because they're not randomized. You could say that there are confounding factors, and that's correct. But that's the best we can do because it's unethical. So he's asking for an unethical study he knows will never be done. And if that's your line in the stand, no other evidence will ever be enough. And that's the goal, right? You guys hear the term sea lion? It's just a new internet meme. It's basically trying to seem reasonable by asking for evidence, but the asking for evidence never ends. And this is a social media strategy now. It's a form of trolling. It's like, oh, do you have a reference for that? Well, do you have a reference for that? Well, do you have a reference for that? And it's just a never-ending recursive loop of asking for more and more evidence or defining of terms. I was like on my own blog, just a few weeks ago, there was a climate change denier who was saying, well, how do you define climate change? And then somebody gave a perfectly reasonable definition. Well, how do you define climate? Well, I mean, you could, look that one up on Wikipedia, I guess. I mean, how basic are we going to get? It was just, but again, the purpose wasn't to really explore the issue. It was just to create this fear and confusion, a fog of questions. Solution aversion. So this is just explaining why do people deny science? And there are as many reasons as there are people and as there are science to deny. But one of the big signals that has come out, this is probably most prominent in global warming denial. Why is there this tribal conservative / Republican denial of the consensus of opinion on climate change? And the answer is pretty clear. And if you've ever debated a climate change denier, this will come up. I guarantee you that's locked and loaded. This is their answer. Because they believe it's part of a global liberal conspiracy to take control of the economy and enact extreme socialist measures. That's what they really think that. And all scientists are controlled by a democratic liberal conspiracy. They really think that. So they fear the proposed solutions to global warming. That's their problem. Of course, my response has always been, well, then propose market-based solutions. Don't deny the science. If you don't like the solutions, propose better solutions. Propose at least different solutions. Don't just deny the science, but whatever. They've chosen to deny the science. Always a losing strategy in the long term, by the way, to be against reality, in my opinion. Here's the moral, here's just an example of the moral hazard. Ken Ham, I'll be quoting him tomorrow night as well. So he's a known, famous young earth creationist. So even when I began teaching on creation versus evolution back in 1975, I was already asserting that atheistic evolution and morality were connected, and that over time immorality would grow as people rejected God's word and accepted evolution, right? So evolution is a moral hazard. So again, it's not the science really that they care about. It's not like they really have a problem with evolutionary science. It's that they think it will lead to immorality, and they think it will lead to the loss of power of their tribal religion, right? It's a culture war. And they want it to be a culture war because they lose the science war, right? So if you're going to lose in the change of venue, right, you're going to lose in the science arena, let's move to a cultural, religious arena where they think they could win. All right, last bit, and then I'll stop for questions. So this is just, again, this I could talk for hours on the misinformation that's out there on every one of these topics, but here is one that is just one of my favorites, partly because I totally owned somebody I was debating who tried to pull this on me in the middle of a debate. and I'll never forget it. It was one of those perfect debate moments. All right, so denial of established facts, spreading incorrect information, distort the facts, cherry pick the facts. So here we go. The guy I was debating threw up this chart, trying to show that the measles vaccine doesn't work, right? So here are measles deaths over time, and as you can see, by the time the measles vaccine was introduced, measles was already dramatically reduced and was on its way out, and the vaccine had no impact. Sounds pretty convincing, right? And if you're somebody who's vaccine hesitant or just doesn't know, a concerned parent, should I vaccinate my kids? And a doctor convincingly presents you with this data, you're like, wow, they've been lying to me. There's a conspiracy, it must be big pharma, right? It all kind of starts to make internal sense. This is why you have that illusion of knowledge. Now you think you know something, but you really don't because you've just been misinformed. Now, just anybody know what the problem here is? This is a graph of measles mortality. Why that might not be a red flag if you're not a doctor who knows how to think about data in a medical data in a sophisticated way. Why did they choose to present a graph of measles mortality and not measles incidence, right? Probably because, well, look how far back they're going, 1900. Not a lot of science-based medicine back in 1900. So what we're seeing there is the generic progress in just science-based medicine. 1900 was before the Flexner Report in 1910, where basically modern medicine began, And then when modern medicine was instituted, yeah, we kept people alive with measles better, right? They didn't die of like basic things, like not breathing, right? But now let's look at the real data, vaccine, measles incidence. Now, the effect of the vaccine is much more obvious. It's a lot harder to say that the vaccine didn't work. Yes, there was some hygiene issues initially, right? Some basic public health sanitation kind of things that were helping initially, but really the incidence is just bouncing around, and then the vaccine was licensed and it plummeted. And then when the dosing was tweaked, it basically went to zero. There were literally years where we had 0 measles cases in this country. It was no longer endemic. All the cases were imported from other countries. There was no spread from person to person within the United States. We eliminated measles. Eradicated means from the world, eliminated from a region. So we can't say eradicate. We eradicated smallpox, but we eliminated measles from the United States with the vaccine. The data is undeniable. So just use different data, right? If you don't like this data, just cherry pick some other data that superficially looks compelling, but is actually misleading in a very specific way. So, this was my moment. I'm like, oh yeah, but look at this data, right? So I basically was able to tell the office, this guy just lied to you, and this is how he lied to you, and here's the actual data. And it was kind of one of those home run moments. Okay, this is, blah, 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 blah. So this is just a denialist statement about global warming from, this is reinforcing the moral hazard thing I was talking about before. So this is a clear and present danger to our liberty and democratic traditions, right? So that's what they care about on global warming, not the science. They think it's a threat to democracy, I do think I have, oh yeah, here we go. This is the last one because this is mental illness denial. Which again, not many people even know exists. Does anybody know who the biggest mental illness denying organization is in the world? Scientology, very good, Scientology. Mental illness denial, there's basically 2 origins of this. One is Scientology. Why do they deny psychiatry? Because it was a competitor. This is pure Coke versus Pepsi competition because Dianetics set themselves up as an alternative to psychiatry. The other reason is Thomas Szasz. Anyone ever hear that name before? Thomas Szasz? Good, I'm glad. He's fading into obscurity. But this was a psychiatrist who came to believe that there was no mental illness, that mental illness, basically his opinion is that mental illness is oppression, that the diagnosis is used as a tool of political oppression. And this is one of those claims that has the virtue of having a kernel of truth in it. Yeah, it is true that oppressive regimes used the diagnosis of mental illness as a way of imprisoning dissidents. Absolutely, that happened. That's a historical fact. Does that mean that all modern psychiatry is political oppression? Of course not. But if you ask Sazians, people who follow his beliefs, for evidence of a truth, they refer to the cases of political, undeniable political oppression. It's just a non sequitur. It's just not relevant. So this is okay, but the anti-psychiatry, anti-mental illness campaigns have leached into everyday life, and unfortunately, some of the non-psychiatric mental health professions have sort of taken it up because it as a way of this, in my opinion, it largely comes down to just turf wars. So if you're a counselor and not a psychiatrist, and you could say those psychiatrists are lying to you and you don't need medications, you just need cognitive behavioral therapy. So again, I'm not painting the whole profession though. My wife is a counselor, for the record. I have no problem with it. I'm saying that some people have adopted the rhetoric of the mental illness deniers, and without really even realizing it, because they think that it's an argument for their treatment modalities or their profession. But anyway, so that's where this quote is coming from. This is not a Scientologist. You always have to ask if someone's mental illness. They're usually, oftentimes they're stealth Scientologists, but even when they're not, they've incorporated the rhetoric. So he's saying, now if your baby dies at 10 a.m., your doctor can diagnose you with a mental illness at 10:01 a.m. and start drugging you straight away, right? So there's a bigger argument here. I don't want to put the whole thing on the screen. He's saying that psychiatrists diagnose normal human emotions as mental illness, right? Normal, healthy, so grief from the loss of a loved one is a normal response. But psychiatrists took the grief exception out of the DSM, right? The Diagnostic and Statistical Manual, the way you diagnose mental illness. Which means that he's then saying, therefore, even if you're a mother who lost a child, the psychiatrist could say, you suffer from the mental illness of depression, and I'm going to treat that with a drug, right? So this is fear of drugs, this sort of false dichotomy. Either you're treating brain chemistry with drugs, or you're using psychotherapy. Actually, most people do both. It's like there's no dichotomy there. And he's cherry picking evidence. There's a kernel of truth at the center of this misinformation. It is true that the grief exception was removed from the DSM. That is true. But he leaves this part out, which is this was put into the DSM, where it basically says you have to take into consideration the life situation of the person. If they are responding to a life event that does not qualify as a symptom of a mental illness. So they didn't take it out. They just put it somewhere else. Mainly actually so that it would apply to everything. Rather than saying there's a grief exception for depression, they said that there's a life event exception for all mental illness. They actually strengthened it and broadened it. But this guy used it as a way to argue that they stealthily snuck it out of there so they could prescribe grieving mothers drugs. Right? You see the misinformation and deception of how subtle that is. But if you're not an expert and you can't pull up the DSM and look at what's actually in there, that all kind of sounds superficially compelling. And then that already is in line with maybe some vague concerns that you have about big pharma or corporations in general from other things that you're being told by big organic or whatever, right? Again, if you're swimming in an information ecosystem where that kind of resonates with the kind of anti-corporate conspiracy mongering, it kind of makes sense to you, right? If you're swimming in a different information ecosystem where oppressive left-wing governments are your boogeyman, well, they'll sell that to you too, right? You could sell a lot of these to either side of the aisle or to different ecosystems with different jargon, with different arguments that resonate. Sometimes they overlap. So like the anti-GMO belief is actually bipartisan. It does not track at all with political party. Why? Because they tell Democrats that it's corporations and they tell Republicans that it's the government. But at the end result is the same, right? You don't want the government, they're approving this because they're corrupt, or you don't want, you can't believe that corporate science, they're just all lying. Ignoring the fact that the vast majority of studies are done by scientists, not funded by corporations nor the government. Don't confuse them with the facts. But anyway, I want to drive home how easy it is to fall into one of these ecosystems of misinformation. And that what we're learning is this is really what's driving science denial. And you have to sort of understand each ecosystem unto itself. There's a host of variables involved. There's this overlap of strategies. They kind of borrow each other's strategies. They use what works. It's evolving. They're getting really good at it. They're getting really good at it. I hate to say that, but damn it, it's really hard for us to keep up with it all. And you have science communicators like myself who are trying to confront all of it. And then you have on the other side, you have multi-million-dollar, sometimes multi-billion-dollar campaigns on one specific issue. So science communicators are pushing back against 100 campaigns of misinformation that are all independently well-funded and are free to evolve for marketing purposes, right? So their feedback loop is what markets the best. Our feedback loop is what's true. What's true does not always sell the best. It's challenging to make those two things work together, to make what's true sell. You kind of need to have common ground. What's that common ground? Facts matter. There's a process that you could follow that will lead to reliable results, right? That some opinions are better than other opinions. And so this is the ultimate end game of the science denier. And this is where I'm going to end. The ultimate end game of all of the various campaigns of science denial is to eliminate facts, to eliminate authority, right? To eliminate reliable journalism and sources of information so that everyone thinks that it's hopeless, that everything is just opinion. You have your facts, I have my alternative facts. You have your sources of information, I have my sources of information. You can cite doctors and scientists, I can cite doctors and scientists. So we all can believe what we want to believe. That's the end game, and that's where we are right now. We are in the end game. And we have to get back somehow. We've got to get back to a time, or I shouldn't even say that. There's no going back. We have to push forward to a new time where once again, we have some way where we have some shared common reality. But those of us who want a society where we have a shared common reality based on logic and evidence are in the minority and underfunded. And we're pushing back against well-funded campaigns of fear, doubt, and misinformation. But we have a lot of enthusiasm, and we're not going anywhere, and we're going to keep plugging away. I do think, to end on a bright note, I do think that the history has borne out a long-term belief that at the end of the day, reality has a distinct advantage. It has an advantage of being true. And at the end of the day, that advantage does tend to accumulate over the long haul. Pseudoscience comes and goes. I think denial campaigns come and go. But the science marches forward in the background the whole time. Here we are. The science is doing great. It is. Science is doing fantastic. Science communication is really exploding. We're getting more sophisticated. We're getting more knowledgeable. There's a lot of research. We're really trying to bring our A game. but damn, we have an uphill battle to fight. But we're doing it, you know, and again, I'm not going to be doom and gloom. I think that we'll be fine in the long run, but we have to fight. I think the one thing that we know now, it's not going to just happen by default, right? Just like democracy. Democracy is not going to just happen by default. I think if there's one thing we learned in the last 3, going on 4 years, just to choose a random interval of time, is that that's the case, right? It's not going to happen by default. It's going to happen if we all jealously defend it. And I think we all need to jealously defend truth, facts, and science. Thank you.
All right, we have time for questions, and I'll bring the microphone around.
So I've spent 20 years in business sales. So I'm always interested in the hook. And the biggest problem that I have, the GMO thing, you know, I run into that all the time because it's in my tribe, so to speak. So it's where, you know, I'm the insider, you trust me, you know me. So I kind of have that in, but man, can it turn ugly and scary fast. Because, and I realize what I'm doing is I'm hitting a belief. It's not just a lack of information in my cases. So I'm always searching for that hook, that elevator pitch to make them want to leave a belief that is so comforting. I feel like I'm ripping someone's banky away.
You are.
And
That's what the
is so
evidence
hard.
shows. Yeah. Go ahead.
That is so hard. I mean, and I know there's no magic answer.
Yeah, so you're right, there's no magic answer. And we're trying to figure out like what the best strategies are. So you're hit upon something that there's been a couple of studies looking at, right? So one thing, you're exactly correct. People don't just have beliefs about facts. We do that too. So if you're talking about a belief that doesn't have any identity, tribal, emotional implications, we're perfectly rational. We incorporate new evidence, we change our beliefs, we have a Bayesian approach to knowledge, it's great. As soon as there's emotions involved, we become irrational. And so what the research is starting to show is that you cannot correct a belief, a false belief or an unscientific belief or a science denial belief with information if there's an emotional hook that the person has. They will resist change. It's debatable whether they will have a backfire effect, will they actually increase their belief. There's some studies show yes, some don't show no. It's probably the exception more than the rule, but it does happen in a couple of studies. But clearly banging your head against the wall with facts is not going to do anything. So what do you have to do? What does work, but this is not easy, is you have to replace their narrative with an alternate narrative. So if somebody has a narrative by which they understand how the world works and have a sense of control over the chaos that is life, that you can't believe corporations, or I'm just making whatever, just picking one at random, or whatever, or the government is always trying to take over power and we have to make sure that they don't destroy free markets, whatever. You have some narrative by which you understand how the world operates. You can't change that narrative with facts. You have to give them an alternate way of understanding the world. I don't feel that the best way to do that is to confront their most cherished belief head on. So when people say, how do I deal with somebody who believes X? My question is always, it depends. What's the context? What's your relationship with that person? And what's your investment in changing them? So first of all, you should not go in with the assumption that you're right, they're wrong, and you're going to change them, right? You should go in with the assumption that we disagree, clearly, and then we need to find common ground. And if you find common ground, you've kind of solved both problems. Because what's the common ground? So I would first say, what common ground do I need to be able to convince this person of my position? So first of all, you better examine your own position, make sure you actually are correct as much as you can be. So first, so like with the GMO thing, you say, okay, can we agree that there are, there's a consensus of scientific studies, if it's done by independent scientists, is reasonably compelling? And let's talk about some other issue. Find an issue you agree on, right? If it's an anti-GMO person, maybe they agree on global warming or they agree about evolution or whatever. You find a topic you agree on and then develop a suite of common ground things. Like conspiracy theories are not valid for these reasons. And this is how we basically evaluate scientific evidence. This is how we know what the consensus is, right? You listen to objective scientific or whatever, you come up with some kind of process, right? So you come up with some kind of common ground way of understanding the world and approaching questions in general. And then you slowly begin to apply it to the thing. Hopefully they'll do it themselves, but you might encourage them gently. It's like, really? So, and this is like how I would sort of go through the back door a little bit. So it's hard for me because I already know all the answers to the questions that I've been writing about for 20 years. But like when somebody says, oh yeah, Monsanto sues farmers for, seeds accidentally blowing into their yard. I wouldn't come right at them, well, that's wrong, that's whatever. You again, depending on who the person is and what your goal is, right? If you just want to score points for a third party who's watching, that may be a fine strategy. But if you're actually invested in that individual person, you could come back the next day with a few articles. And you know what, I was very interested in that question. I wanted to know what the actual truth was. So I found some interesting articles that shows that it's never actually happened. What do you think about that? And maybe let's search together to see if we could find any examples of it actually happening. But again, you have to have some common ground. I need a original source, right? Let's agree we're not going to rely on secondary sources of information, because somebody who is engaged in a campaign of denial they'll lie about the evidence, or maybe they're misinformed. They're just paying misinformation forward. So again, you have to sort of build this common ground of critical thinking and understanding how science works, and then you could begin bit by bit to sort of deconstruct their narrative, and then you give them a critical thinking science-based narrative in its place. And then when it works well, you have somebody who feels empowered by actual information. And you've given them a really powerful narrative, because skeptical thinking is really powerful. Scientific thinking, again, I think it's an inherent advantage to our side. It's really powerful. It's literally empowering. And so that's sort of the shortest path to doing that. There is no quick shortcut. You have to, and if you're not invested in that person, then you could do whatever you want, whatever makes you feel good. But unless you're sort of in for the long haul, you're not going to make any difference, to be honest with you.
Hello. So I'm a conservative libertarian. I'm proud of it too. I accept the science consensus of climate change. And I do believe that nuclear energy and hydroelectricity is the way to go. But do you think that the denial of climate change comes from the evidence or the propping up of certain people who say things like, who misinterpret the data to say things like the world's going to end in 12 years?
Yeah. Right.
Which happens on both sides, by the way, not just like for creationism can have people propping him up. Just, do you think it's...
So with global warming, we know the answer, right? Because this has happened in recent history, and it's all well documented. And it's very simple. The fossil fuel industry hired the exact same people as the tobacco industry was using a couple of decades earlier, and they employed the exact same strategy of FUD, right? Fear, uncertainty, and doubt, that was employed to deny the connection between smoking and cancer, to deny the connection between burning fossil fuels and climate change, right? So we know who the people are. We know who's funding them. It's all documented. There was a case in New York where they sued Exxon, where all the data came out. The result of the case is irrelevant. The important thing is it's all documented. They knew about it. The executives, there's documentation of what they were doing. You can follow the money, in this case, and you know who's funding the people. They cherry-picked 2 or 3 dissident climate scientists who are in the minority, Spencer and some whatever. You hear the same 2 or 3 names come up all the time. Why is it those same 2 or 3 guys? Because those are the guys who are being paid by the fossil fuel industry to spread fear. They may have believed it ahead of time. And again, a lot of this is what industry does in general. Again, it's a continuum. It's not a black or white thing. Like in medicine, pharmaceutical companies don't tell physicians what to say. They just pick the physicians who are already saying what they want to be said, and then they fund them to say it more, right? So I don't think that the fossil fuel industry like paid people to say things. They just picked the people who were already saying what they wanted to say and then amplified their voice. And then the conservative ecosystem megaphoned it, amplified it incredibly. And again, then you get this, so we know what the funding source was, we know what the origin was, we know who the primary players were because they're the same people who were involved in the previous campaign of FUD. And then we know the conservative media ecosystem then just amplified it and megaphoned it. And then it took on a life of its own, right? I don't think the fossil fuel industry doesn't have to do anything anymore. It's done. They've accomplished their goal. They created a self-sustaining political movement, so that's what happened. It's well documented. There's not really much, there's no really alternate way to make sense of all the data that we have.
So, it's hot. Thank you for the talk. It was very interesting. My question is, what do you think is the most valuable criteria to use when distinguishing between valid information and misinformation?
So that's a really good question. So how do we know what information to trust? There's no short answer to this, but you do need to follow a process. So I'll give you sort of a quickie version of my process. So first of all, I just look for whatever information is out there, right? And then I try to find out what are all the things that different sources are saying. So don't trust any single source. You find sources that are traditionally reliable and you track them back to their original source. So you have to go to primary sources. Don't rely on secondary or tertiary sources, right? So you want to find a variety of primary objective sources. And then if there's a controversy, you want to see how that controversy plays out to its conclusion. So if side A says one thing, well, what do people who disagree with them say? And why do they say it? And then how do they answer their disagreement? And then until you play that out to its conclusion, you don't know who really has the better side, right? And we could give you, this could be a mundane example, like if you talk about, did the asteroid kill the dinosaurs or did the volcanoes kill them? Well, what do the two sides say? What's the evidence that they have? How does the other side answer that evidence? And then where do most of the experts come down on all of that evidence? And how confident do they say they are in their conclusions? And you make a decision based upon all of that. So there's no really shortcut to it. I guess if you're figuring out by yourself, the only real shortcut is to listen to somebody you trust who did that, right? So, but then you're putting a lot of trust in that person. But we do that. I do that. Everyone does that because you can't be an expert on everything, right? And you can't do that. I mean, I'm a science communicator, so I do this for a living. But even I will say, if somebody is an expert on something, I'll say, tell me what the bottom line here is. So if you've done your due diligence and really poured through the evidence and the controversy, where is the consensus of evidence and objective opinion here? And it at least gives you a shortcut to knowing what's probably true. That's the kind of process you have to do. So always know what all the sides are saying. Don't believe one side. Go to primary sources and see who has the better, exchange in the end.
Hey, Doc. With your background in neuroscience, I think it'd be interesting for you to talk to some of the neurophysiology and the different pathways that are occurring. And where I'm going with that is your Kinham quote, if I'm not mistaken, was the one that equated atheistic evolution to morality, and therefore it was something detrimental. And so what we would probably mark it up to is simple cognitive dissonance or inadequacies. And what I mean by that is for them to base immorality off of evolution while completely not acknowledging that their own book, their own theistic framework that they're operating off of and I guess you could go wide branching religions here, but justifications for keeping slaves, justifications for mistreatment of women, mass genocide, slaughtering Amalekites, things like that, to say, okay, based on your book, evolution is going to be immoral, but we're going to completely negate all the immoral factors from our book and not apply that.
Yeah. So just on that point, it's philosophy denial and history denial. Absolutely. You have to deny that there is a philosophy of ethics. There's a whole branch of ethics that deals with, a whole branch of philosophy that deals with ethics, and they just sort of pretend that that doesn't exist. You need their theological faith in order to have morality, which is demonstrably not true. And in fact, the scholars tell me, right, again, not my opinion, but those who know what they're talking about, the consensus of opinion is that Christian morality evolved out of Greek philosophy. Though theology is philosophy. They just lost their historical knowledge of where it came from. But anyway, I have a whole hour-long lecture on the neuroscience of belief. I can't give that to you in a nutshell, but I'm going to tell you one thing that I think is really fascinating. There was a study, there was an fMRI study, and again, this is just a sort of the capstone of a suite of neuroscientific evidence, but they were looking at people who were listening to charismatic speakers and trying to say, what's happening in the brain when you're listening to a charismatic speaker? And they divided them into two groups, listening to a charismatic speaker in your tribe and listening to a charismatic speaker from a different tribe. And they used religion. So they said, if you're a fundamentalist Christian and you're listening to a fundamentalist Christian preacher, what's happening in the brain? If you're listening to a Muslim cleric, what's happening in the brain? Right, that was the study, and they used fMRIs to look at what different parts of the brain. They knew what parts to look at from other research, where we know that there's a reality testing section, and there's basically the skeptical part of your brain. I mean, it literally exists. There's the part of your brain that challenges truthfulness, and decides, is that really real? It asks the question, is that really real? And what they found was fascinating. They found that when you're listening to a charismatic speaker in your tribe, but not from another tribe, the critical thinking, questioning part of your brain turns off. Literally, they could see the part of your brain that tests reality was disinhibited when they were listening to a charismatic speaker. They were literally, we often say that they were hypnotizing the crowd or mesmerizing the crowd. It turns out that's literally true. A charismatic speaker in your tribe can literally cause you to turn off your questioning, your critical thinking, your skepticism, and you just absorb it, you accept it. But there's a lot of those kinds of studies that are looking at what's happening in the brain, how do we form beliefs. It's fascinating stuff.
Thank you.
So the gentleman in the back asked a question about evaluating sources and how do we trust that? My question goes to, as a layperson, sometimes getting to primary sources is not readily available. How do you feel about making the information for primary sources available free to public? In other words, lowering them from the ivory tower and giving better access.
Yeah. So access to primary sources to the public. So that is the open access movement, right? So that already exists. And it's great. And I think everyone is pretty much in favor of that, the open access thing. The problem is, what's the business model of open access journals? And so they decide, okay, well, we're going to take the business model. So the classic model for traditional journals is they advertise, right? So they pay for it with advertisement, and the advertisement is based upon their impact factor, right? So you want to have impactful studies that other people cite, gets a lot of mention, and then you sell advertising, and that's your business model. The open access model, because it doesn't, or subscriptions, right? So you want people will subscribe to your journal because they need your high impact articles, right? But that restricts access to it. The open access model is we won't charge subscriptions. What we'll do is have the authors pay to publish in the journal. So you pay $200, $400, $500, whatever, to get to cover the publishing costs of your study to make it open access to the world. And scientists do that. That's not that big a deal. You spend $50,000 to do a study, paying $200 to get it published is not a big deal, right? But what that created was a marketplace of predatory open access journals who publish any shit as long as you pay them $200, right? And that flooded the journal market with these trash predatory journals that don't really do peer review and will publish anything literally, and they've been exposed through multiple stings. But there's a problem on both ends, right? So the traditional journals will publish things that have a high impact. What's a study that has a high impact? It's not just about quality. You would hope that it would be primarily driven by quality. It really isn't. It's driven by how contrary it is to what people already believe, how sensational it is, right? Because if you publish a study that says, that thing that you believed for the last 20 years, it turns out it's true. So you don't have, nobody's, or I did an exact replication of this other guy's study and showed the same thing that he showed. Really critical in science. Nobody wants to publish that. The impact is negligible. But they want to publish, that thing that we're practicing, it turns out it's wrong. We have to reconsider. Everyone's going to read that article and cite that article. Those are also the articles that are most likely to not be true, to be retracted, and to be contradicted by later research. So the traditional journals publish things which are likely to be wrong because they're contradictory, and the open access journals publish things wrong because they're predatory. Now, of course, there are high quality journals in both camps, but both business models have their perverse incentives, right? And there's no model that has no perverse incentives. It's basically just you have to choose your perverse incentives, and then you have to police through whatever editorial policy and transparency and watchdog groups and whatever. So again, this gets to, like, if you're a lay person and you go on PubMed and find an article and read the article, do you know the reputation of the journal, the impact factor? Do you know the authors? Do you know whether it was replicated or not? Do you know, whatever, the peer review process? That, no. Do people who live in that small specialty, they know everyone, they know everything. They know who the peer reviewers are, they know the publishers, they know the journal intimately. They're intimate, they live in that system. So you're never gonna, I'm never going to have the same, like, I'm a scientist, I can read technical journals, I have a pretty good, this is what I write about, how to dissect a technical journal, an article, and know if it's reliable or not. But even still, I cannot get a sense of really how reliable a study is if it's outside of my ecosystem, outside of my area of expertise. I have to ask somebody who lives in that system, hey, do you know these guys? Are they, are they for real? What's the deal with this? And they give you, there's always a backstory. Every time I ask the actual researchers or somebody who's in that field about a study, there's always a backstory that's different than what I thought it was when I read the article. You know what I mean? So that gets to, like, how do you really know? You have to listen to the experts. I'm sorry, but there's just no way. If you're not an expert, you have no idea what's really happening. I'm sorry, but that's the way it is. That's modern science. So you have to listen to a consensus of objective expert opinion. So how do you get that? Not by listening to one guy, because you have no idea if they're representative or not. So professional organizations and scientific organizations will publish consensus opinions where they put together a panel of diverse experts who then pour through the data and come up with a consensus of opinion. That's a good place to start. But even that could be biased, because who did they choose on their committee? Like, who were the panelists? Was it really representative, et cetera? Did they have a political bias, But if you get a consensus of multiple different scientific organizations that are generally reliable, now you're talking, right? So that's where I begin. Did the AAAS and the professional organization and the whatever, just so you find 5 or 6 or 7 professional organizations relevant to that question, are they all saying the same thing? Okay, that's probably true then. You know what I mean? And does it make sense? Do they have a coherent story to tell? If there's a lot of disagreement, then not so much. If it's from There's a group called the Environmental Working Group, not to pick on them, but just one off the top of my head. They sound like a respectable scientific organization, but they're really not. They're really a political organization. So even if there are scientists involved, if their reason for existing is a political agenda, I don't take them as seriously as I do a dedicated science organization, right? Like the AAAS, for example, the American Association for the Advancement of Science. They exist for science, not for some other political agenda. So it's hard, which I get it. That's why there's so much confusion out there. And that's where the role of science communicators comes in, right? That's how I see my role is. My role is to translate what the consensus of expert opinion is for the public and to explain how I came up with that understanding of what the consensus of expert opinion is. Because it takes a lot of work. There are some questions that came across, like somebody asked me about a question, like at the first time I was asked about thimerosal in vaccines. I spent 6 months researching it before I wrote about it. That's how long it took me to wrap my head around the evidence. I didn't write about recycling for 2 years until I felt I had wrapped my head around the consensus of opinion, because it's all over the place, There are issues I still haven't written about because I still am not sure. Sometimes I get asked, or I want to know a very specific question. What's the effect of raising the minimum wage on unemployment? That's kind of an important question. I know that people give a lot of answers to that question, but I want to know what the science says about that question, not what the politicians say about that question. The answer is, right now, I don't know. I don't know what the answer to that question is well enough to write about it, so I'm not going to write about it. If I feel I get to the point where I do understand the answer well enough, then maybe I will digest that. But what I found so far is that different economists tell completely different stories based upon the same data, depending entirely on their ideological background. Maybe I won't ever get to the point where there's an objective scientific answer. I don't know. Maybe we need new research. Maybe the existing research doesn't have an answer. But that's what I do every day, is pick a question. What does the evidence say? What's the consensus of opinion? It's a long, hard process. And it takes, if it's a controversial question, it's really hard. And it takes me a long time to get there. So I get it. I don't expect people to just be able to look up on Wikipedia and find out what the answer is. And that's in the best case scenario. If you have a dedicated campaign of misinformation, that makes it 100 times harder. There's a question over here, I think.
Yes. So we'll do one more question, and then I invite you all to, there's the book signing afterwards, if you're interested in picking up a book.
This one should probably be pretty short. So,
okay. Never assume. I can give a long answer to any question, trust me.
As someone who is very much not an expert in anything and has a lot more to learn about just about every subject in the world, I tend to still also have a lot of friends and even family members who are the sort of, I know a lot more about this subject than they actually do, and try to spread misinformation. And I never know how to counter that, how to try to help them understand, because I know I don't fully understand. Yeah. Is there anything I could do as someone in my position?
First of all, it's okay to say, I don't know. It's okay to say that. That's fine. And it's okay to say, you know what, I don't think you know either. I do, it's fine. I often will say, let's just both agree that neither of us know the answer to this question. Like when I get into an argument with somebody about something that neither of us are experts in, especially with something that's happening out there in the political world or whatever happening out there in the world, I say, all right, let's first just both agree that neither of us actually know what's going on here. We only know what the media is telling us or whatever, and we're probably listening to different sources. So let's just back up and start with a position of maximal humility. And then let's talk about how we can proceed from there. Again, find common ground. Is there a reference that we could find that we would both trust? Or is there any way that we can move forward on this? That's the approach that I would take. Because again, let's face it, most people don't really understand anything. And, or let me put that another way, most of the things people think they know about, they don't know about. And here's my go-to demonstration of that. I just told this to the students over lunch. if you do have some, whatever, think of the thing that you know the most about. Whatever, it could be something, you know, a sport, a hobby, it doesn't have to be your job, anything you're interested in, you know, literature, whatever, just something that you think you know more than the average person. Especially if you have real expertise in something. Think about how much you know about that, and then think about the things that everyone else you encounter thinks they know about it, right? So most other people you encounter, unless they share your interest, don't know anything about it, and the things they think they know are probably wrong, right? So the thing you have to realize is that everybody has that experience with their expertise, and that for everything other than your expertise, that's you, right? You are just as ignorant and misinformed about everything outside of your area of expertise. That should be humbling. You're not the only person who is frustrated by how everyone else is misinformed by, it's not just your area of expertise. Why does everybody misunderstand my one expertise? No, people have the same level of misunderstanding and ignorance about everything. That's just the baseline. That's the way it is. So I think that's how I would approach that. It's okay to say, listen, I don't know about that. I've never looked into it. I usually say I've never done a deep dive on that. I don't really know what's going on, So let me do that. Where could we find a reliable source of information about that? But I think if you sort of get them to agree on that common ground that neither of you really know, and if they say they know, say, yeah, but are you a scientist? Have you published on that, or why do you think you know about that? Because you've read about it. We can't trust these third parties. So again, you need to find some common ground, basic, like how we know things, common ground. If you can't even get to that, probably don't waste your time. Seriously. Not too long ago, I literally had somebody, this was a global warming denier, who said, I don't trust studies. It's like, nice talking with you. I had no common ground. Where do I go from there? Like, you don't trust science. There's no evidence I could bring to bear to change your mind. Okay, but let's talk about that first. Let's talk about your complete lack of trust in science. We can't talk about any specific topic before we deal with that, right? Or like, everything you know is wrong because it's all a conspiracy. It's like, okay, well, unless we address that issue, no other conversation is useful. So I told you I'd give a long answer. Anything else? All right, thank you.
Yes, thank you, Dr. Novella. And again, stick around for book signing if you'd like to talk more with him.
Thank you very much.
Thank you.
See you tomorrow at lunch.
Yeah. All right, see you.
Oh, you're still on.
Oh.